Very good morning to you. Welcome to today's class. So, in this class, we'll be discussing about the circular queues. It is circular representation of the queues. In the previous class, we have seen about the linked implementation of a queue. We have discussed about how we can implement the queue, that is linear queue, by using linked list. We have also implemented the program for that. In this class, we'll be studying about another variation of the queue data structure, that is circular queue. So circular queue is also a type of queue which is arranged in such a way that the rear end of the queue is immediately followed by the front end of the queue. That is how the circular queue will be existing. That is how the circular queue will be existing. That is, the start location is coming immediately after the end location. For the given queue, if the start location is coming immediately after the end location, then that particular queue is called as a circular queue. That queue is called as a circular queue. So this is what is the definition of the circular queue. Now let us see why we have to go for the circular queue. Even though we have the linear queue, you should know why actually we have to go for the circular queue. That is, what is the advantage of having circular queue? Or you may also be asked a tricky question like this. What are the disadvantages of the linear queue and why you have to go for the circular queue? So the circular queues are going to remove the main disadvantage of array implementation or the linear queues, in which lot of memory space is getting wasted due to inefficient utilization. That means in the linear queue or array representation of the linear queue, most of the memory is getting wasted. Unnecessarily, the memory may get wasted. That's why we have to go for the circular queue. Now let us see the scenario why the memory gets wasted in linear queues or array representation of the queues. How the memory gets wasted. So if you consider one sample queue, this is a linear queue which has the name for this is queue, which has 5 memory locations 0, 1, 2, 3, 4. So assume in real time there will be so many memory locations around 100, 200, 500, whatever size you can consider. Right? This is a linear queue which has a size of 10. That means it can store and process 10 elements at a time. It can store and process 10 elements at a time. Now, usually what we know here is, assume these are the elements in this case 10, 20, 30, 40. You have inserted all the numbers and then at the last you have inserted 100. In this scenario, what happens here is, we know that rear end is pointing to this location and front end is pointing to this location. This is the scenario when we have declared a queue and we have inserted 10 elements into the linear queue. We have inserted 10 elements into the linear queue. And whenever we have inserted 10 elements to the linear queue, rear is the pointer which will be pointing to the last index. Which will be pointing to the last index. And if you want to insert one more element here, it is not possible. Why? Because maximum capacity of the linear queue is over. We cannot store the new elements onto the queue. We cannot store new elements onto the queue. So that is what we already know. Now let us see the scenario. What is that scenario? If you want to delete the element from the queue, what is the procedure? We will remove the element from the front end. Then what we do? We advance the front pointer. That means front pointer will be made to point to the next location. If you want to delete one more element from the queue, what is the procedure? We will remove the element from the front end of the queue and then we advance the front pointer, make it to point to the next element which is present at the front of the queue. Make it to point to the next element which is present at the front of the queue. To delete one more element, remove the front element from the queue and then advance the front point. This is what we do. Now assume if you go on deleting like this, so assume this is number 90. You have deleted, you have removed all the elements. Let us assume that Likewise, you have removed all these elements, and somewhere the front is pointing to this index now. Somewhere the front is pointing to this index. Now, if you consider this linear cube, what is the size of this linear cube? Size of this linear cube is it can hold 10 elements. Now, where rear is pointing to last index. And how many locations are free in the linear cube? In this linear cube, 8 locations are free. 8 locations are free. So these many locations are free in this particular linear cube. Now, if you want to insert one more element into the queue, it is not possible. Why it is not possible? It says that queue is full. We got a message saying that queue is full. Why queue is full? Because rear is pointing to the maximum index. Because what we check the condition in case of linear queue, whether the rear is pointing to maximum capacity of the queue minus 1. What is the maximum capacity in this queue? Maximum capacity is 10. 10 minus 1 is 9. So rear is pointing to 9. In this scenario, queue is full. Even though there are 8 memory locations, and these 8 memory locations will get unnecessarily wasted. Unnecessarily, they will get wasted. They will get wasted. So this is what is disadvantage of the linear queue or disadvantage of array representation of the linear queue. So this is simple scenario. If you assume you have reserved size of 1000 memory locations and assume only last 2 memory locations are present and you have removed all the elements, remaining 999 elements you have removed. In that case, what happens? All those memory locations are not occupied by any of the elements, but still queue is full. Why? Because rear is pointing to maximum index minus 1. To overcome this disadvantage, we go for linear queues. What happens in case of we go for circular queues? So how to represent the circular queue now? Circular queue is the one in which the rear end is immediately followed by the front end. So as to wrap around, you have to wrap it and make sure that rear end is followed by the front end. So this is the queue which are having indexes like this 0, 1, 2, 3, 4. Now this queue, what you have to do is you have to bend it, rotate it and make it a circle. That means this linear queue, this is a linear queue and which will be converted into the circular queue, something like this. Right, this is made as a circle now. 1, 2, 3, 4, 5. 5 indexes the same size. This is array index 0, array index 1, 2, 3 and 4. 1, 2, 3 and 4. So in which if you assume this as the front end, so assume I am going to insert elements 10, 20, 30, 40 and 50. In this case, front is pointing to index 0 and rear is pointing to index 4. Front is pointing to index 0 and rear is pointing to index 4. If you assume that in case of circular queue, front is pointing to index 0 and rear is pointing to index 4. This is how we convert the linear queue to circular queue. Now come back to the definition. So what the definition says? A circular queue is a queue whose start and end locations are logically connected with each other. They are logically connected. That means start end is immediately followed by the front end. So that's what we have arrived at this situation now. 10, 20, 30, 40 and 50. Logically, if you see, they are connected. The front end is immediately, the rear end is immediately followed by the front end. That means they are connected because the linear cube is bent and made it in the form of a circle. It means we will not fix the front and rear in case of circular cube. Front and rear both will be moving based on the need. Front and rear, both ends will be moving based on the need. If the memory location is available, we can utilize that. We can utilize that if the memory location is available. So let us see one example scenario which is given in the textbook. So this is one empty queue whose size is 7. It can hold 7 elements. It can hold 7 elements. So index 0, start is pointing to index 0 and end is pointing to index 7. This is one empty queue. This is one empty queue, empty circular queue. Now, when you want to insert an element, if you want to say after this scenario, we will go take another scenario from this empty queue. So let us take one scenario that is front is as usual, it is pointing to the first element. This is the scenario when we have inserted 4 elements into the queue. The queue was empty and we have inserted 4 elements into the queue. That means how we come across this situation is, it is shown directly in the textbook. I'll just try to show it because understanding fundamentals is important. Right? 1, 2, 3, 4, 5, 6, 7. Okay, indexes are starting from somewhat, I'll take it as 0, 1, 2, 3, 4, 5, and 6. Index value 1, 2, 3, 4, 5, 6, 7, 8 locations they have considered here. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, index 0, 1, 2, 3, 4, 5, 6, and 7. In the beginning, we can make front and rear both to point to -1, which are not pointing to the queue. Now, automatically, when you insert one element, rear will be made to point to 0, and immediately front will also point to the very first element or front element of the queue, because both are joined here. Both are joined. For some time, I should take help of linear. 1, 2, 3, 4, 5, 6, 7, and 8. Index value 0, 1, 2, 3, 4, 5, 6, 7. Now rear has been incremented, and in that location we have stored an element called 10. This corresponding linear. And what is the property of the front pointer? Front pointer should always point to the first element. So front is made to point to 0. This is what is the scenario now. This is what is the scenario, and the same thing is shown in the circular queue. The same thing is shown in the circular queue also. Right? What are the elements? 22, 8, 43, -2. So any elements you can insert. Now later, if you want to insert one more element, say 20, what is the procedure? We will increment the rear and there we store the element in case of linear queue. Similarly, for circular queue, we will increment the index, make rear to point to the next location, and there you store the element. This is what is the simple procedure what we follow for insertion. Right? Same corresponding linear queue is being shown here for understanding purpose. If you insert one more element, say 30, where rear is pointing to this location. If you insert one more element 40, where rear is pointing to this index. So that is 30 and 40. Okay, 4 elements we have inserted. Rear is pointing to index 3 here, and rear is pointing to index 3. Same corresponding, I am showing it in the linear queue. Now this is the same scenario which is shown in the textbook. Rear pointing to index 3, rear is pointing to index 3, and front is pointing to index 0. This is the scenario when we have inserted 4 elements. When we have inserted 4 elements into the queue. Now assume that likewise we go on inserting all the elements, say 50, 60, 70, and 80. In this case, where rear is pointing to this element. So I have directly written, hope you can understand. I have directly written We go on inserting all the elements. Now rear is pointing to index 7 and front is pointing to index 0. So you can imagine, compare with this scenario. What this scenario says, rear is pointing to index 7 and and front is pointing to index 0. Front is pointing to index 0 and rear is pointing to index 7. This is what is the scenario. Here it is wrong in the textbook. It must be front end. They have given it wrong. Okay, it must be front end. Now in this scenario, correspondingly I will show the linear queue 50, 60, 70 and 80. Okay, let us just erase and make sure the rear is pointing to index 7. Same corresponding, it is linear fashion and this is circular fashion, because what happens in the linear queue, just take the last end and attach it with the front end. That's it. Just take the last end and attach it to the front end. That is, this linear itself, if you make it, okay, now that is difficult to show. Okay, right? In this scenario, usually what happens, if you delete 4 elements, how many elements they have removed here? 1, 2, 4 elements. How do we delete elements from the queue? From the front end. What is the procedure for deletion? Remove the element from the front end, then advance the front pointer. Next, to delete next element, remove the element from the front, then front will be made to point to next location. Remove this, make front to point here. Remove this, make front to point here. Now ultimately where front is pointing? Front is pointing to index 4. So your front is pointing to index 4. These are simply some scenarios which will help you to show how the circular queue is going to function. Now if you delete element from the front end of the circular queue, what we do? We remove the element from the front end, then make front to point to the next location. Right? Now front will get advanced and it is coming to the index 1. Right? Similarly, we have to remove this, and I'll simply delete how many elements? 4 elements now. We'll remove 20, we'll remove 30, and then we'll remove 40. Now where front is pointing? Front should point to the front element in the queue. That is, it is pointing to index 4. In the simple scenario, what I have shown, how the circular queue is going to function. Circular queue, how it is going to function. Now in this scenario, if you say that, if you consider in case of linear, what happens? If you consider in case of linear, rear is pointing to the maximum index, there is no next free location in case of linear queue. There is no next free location in case of linear queue. We will get queue as full. That is linear queue as full in case of linear queue. In case of circular queue, what we can do here is, there are still 4 memory locations available. 4 memory locations are freely available. So what we can do now is, we can still increment this rear and make it to point to next index in the circle, provided that memory location is free. Make sure that provided that memory location is free. How do we come to know that memory location is free? If front is not pointing here, because front is pointing to index 4 and rear is pointing to index 7, it is understood that these 4 locations are free. It is understood that these 4 locations are free. In that case, what we can do here is, we can still increase rear, make it again circle, bring it back to the again first location. If it is freely available, we advance the rear pointer and there we can store the next element. This is what is the advantage of the circular queue. In circular queue, what we can do here is, we can utilize the memory locations. If some memory location is unnecessarily getting wasted, as in case of linear queue, here we cannot utilize this. These memory locations are getting wasted in case of linear fashion, whereas in case of circular queue, what we can do here is, we still have possibilities to increase the rear and store the element. Similarly, if you want to go for storing one more element, it is possible. This is index 1. Take rear and make it to point to next possible location, then store the element, next possible element 100. We will erase this. Similarly, what is possible now? One more element can be stored. Increment the rear and store one more element called 110. Because it is a circular cube. Still, if you want one more element, you can store. Increment the rear and then there we store the new element called 120. This is how the circular cube is going to function. This is how the circular cube is going to function. Now at this scenario, it is not possible for us to insert one more element. It is not possible for us to insert one more element. Why it is not possible for us to insert? Because rear, that is what we say here is, if front and rear they are adjacent to each other, that is one condition. Another one is front is equal to rear plus 1. Front is equal to rear plus 1. In this scenario, we say that circular cube is full. That is, if front is equal to rear plus 1, rear is pointing to index 3, front is pointing to 4. This is one condition. And another way is, if rear is equal to 4, that is if the maximum cube size, that is another case how we check. That is another case. This is very specific. Let us go for generic now. Generic, what happens? If front is rear plus 1, in that case what we do, the circular cube is full. In other way, the circular cube will not be full. Why? Because it is possible that just their neighbor, it doesn't mean that circular cube is full. When circular cube is full, when this condition is going to be satisfied. So how? I'll explain. I'll take this scenario. If you delete this 50, what happens? Front should be incremented and made to point to this index. If you delete 60, front should be advanced and you should make it to point to 60. This index, front should point here. Now likewise, what I'll do, I'll go on deleting all the elements. Likewise, I'll go on deleting all the elements and I'll make front to point here. It is possible after deleting these many elements, all the elements from the front end, it is possible that okay, 1 second, I have deleted an extra element. After deleting all these elements, right, this, it could be possible we'll get this scenario in the circular cube whenever we are inserting and deleting some elements. In this case also, front and rear are neighbor to each other, but circular cube is not full. Why? Because there are still locations available in the circular cube. So when we say circular cube is full only when front is rear plus 1. They are neighbors, but immediately it is following. The rear is plus 1 to the front. In that case, we say circular cube is full. There is another condition to check the circular cube, very specific. We will combine these two conditions. Both together will satisfy the circular cube full conditions. We'll combine these two and study later. Now this way, this was about the fundamental about the circular cube. Hope you got the idea of circular cube, why we have to go for circular cube and how the insertion and deletion will take place in case of circular cube. Now let us see the insert and the delete operations. The things what we have to follow. That is the procedure to be followed for inserting an element onto the circular cube. As usual, we'll follow the procedure like linear cube. First, we will check whether the linear cube is full. That is, before you insert an element onto the cube, the first thing is we have to check whether cube is already full. Because if it is already full, we cannot insert elements onto the circular cube. How do we check? By using this condition and some other additional condition. We have two conditions for that. We'll discuss later. While telling about algorithms and the programs will come through. This is just a procedure. Then during insertion, as usual, what you have to do, you have to increment the rear and then you go on storing the elements. Whenever you are inserting, there are possibilities that you have three conditions. If the cube is totally empty, it is possible. The circular cube is totally empty. In that case, what we do, front and rear both will be made to point to the first location that I have explained you, I think, in this case. Well, when I was explaining about this, when circular queue is totally empty, front and rear both will be made to point to 0. That is first thing. Another case is if rear is pointing to the last location. If rear is pointing to the last location, this is what I said here. When the circular queue was full, and still there were some memory locations available, then what we do, we will bring it back and make it to point to the first location. That means if rear is pointing to the last location in the queue, and in that case set rear to point to the first location in the queue. That is what I explained. Probably if you remember it or not, I think you can make it out. When 1 second, quickly I'll draw that. Okay, it is rear is pointing here, say some element 50 and some element 40, and rear is pointing here, front is pointing here. In this scenario, this is what the case 2 addresses. If rear is pointing at the last location, here rear is pointing at the last location. Index values 0, 1, 2, 3, and 4. These are the index values. Obviously, in this case, rear is pointing to the last location, but queue is not full. Circular queue is not full. In this case, what we have to do, we have to take this advance and make it to point to the first location. That's what it is there. Set rear to point to the first location in the circular queue. In this, if this is a scenario, take this rear and make it to point to the first location. Make it to point to the first location. That is what we have to concentrate. Another possibility is if none of the above situations are exist, then simply increment the rear. That is usual thing. Usually thing is what is happening here is circular queue is not full. Just now you have started entering the elements. Simply what you do, simply increment the rear pointer by 1 and then store the element. Step 3 is simply store the new element at the rear location. So that is the procedure, simple procedure for inserting elements of the circular queue. Right? Now let us see the specific steps, algorithmic steps for inserting elements onto the circular queue. Right? This is what is the algorithm. Quickly, I'll take it to the word location so that explanation will be easy. I hope this font size is visible to you. Because I'll get space here for writing. Now things are set. I can go. Right? So we are trying to insert elements onto the circular queue. What parameters it will take? The maximum possible size, the queue along with its maximum possible size, front pointer, rear pointer, and the element which you want to insert. So these are the initial pointers. So these are the initial pointers for the circular queue. That is for inserting an element onto the circular queue. So we'll first begin. So whenever you have the circular queue, let us assume that the circular queue is of this size. If you are not able to see these elements, whatever I am drawing, you just let me know so that I can increase the size. Because for me, I feel that they are visible to you. You should just let me know if it is not visible. Let us start with the index 0 here, 1, 2, 3 and 4. I'll assume these are the indices. And how do we begin? We will make front to in the beginning we assume that they are pointing to null because we have not yet started the insertion. We have not yet started the insertion of elements. Now say input for our circular queue is 10, 20, 30, 40 and 50. These are the 5 elements what we're trying to insert onto the circular queue. The very first thing is whenever your circular queue is empty. How do you come to know the circular queue is empty? If not circular queue is empty, circular queue is full. So let us assume that front and rear both are either pointing to null or -1 in the beginning. Anything you can assume, either -1 or null. Now what this scenario is, this is the scenario when the circular queue is empty and we are simply starting the process now. We are simply starting the process of insertion of elements onto the circular queue. Now, before you insert an element onto the circular queue, we have to check one condition. What is that? Whether circular queue is full. How do you say circular queue is full? If front is equal to 0 or rear is equal to maximum -1. Is it the case in our case? No, because both are pointing to -1. It is not the case. That means there is a space available in the circular queue. We can still insert the element. Then else part what it says, we have to go to step 4. Else part what it says, you have to go to step 4. In step 4, what it does, if front is equal to null, go to step 5. That means in this case, front is also equal to null. As I said, we are going to, this algorithm, they have assumed it as they are going to initialize front and rear to null, not to -1. Anything you can assume. You can write algorithm in that way also. But what they have assumed in this particular case is they have assumed it as null. Front and rear both are pointing to null. Now the condition here is if front is equal to null, then go to step 5. In this case, it is true, front is equal to null because none of the elements are inserted till now. What step 5 says that front and rear both to point to 0 because this is the first element what we are trying to insert. Then what you do, take front, make it 0 and rear make it 0 because this is where we start inserting and this is where we start deleting. Now once we have set the pointers, corresponding pointers in step number 5. 1 second. Right. So once you have set the corresponding pointer in step number 5, immediate step what it says, check whether set front equal to set front and rear to 0. So that we have set. I think it has got erased. Rear is pointing to 0. Check whenever you are inserting. Now you have to check whether if rear is max -1. 1 second. Okay, whether rear is max -1. So what is max in this case? Max is maximum capacity of this circular queue. For this circular queue, maximum capacity is 5. So is rear equal to 5 minus 1? No, it is not pointing here. In that case, what we do, we go to step 7, then set it 0. Else, in this case, we are going to step 8. Why? Because it is not coming back and pointing at the beginning. This is the fresh queue and we are inserting very first element in the circular queue. We'll go to step 8. What step 8 says? This is normal increment. Simply increment the rear pointer and there you store the element. That is simply perform rear equal to rear plus 1. So this rear equal to rear plus 1 which already we have done. Rear has been pointing to this location. And then where we do, we insert rear equal to 1 second. See, this is I I forgot step number. I think I skipped this step number 7. Step number 7, what you have to do? Rear you have to set 0. So rear is set to 0 already. I think I did it well in advance before coming to this step. So step 8, what we do? 1 second. Somewhere one step I skipped, what I feel. Set front equal to 0, rear is equal to 0. Front equal to 0. Whether I have copied all this, yes, front equal to 0, rear equal to max minus 1. This is the case only when the cube is full. Else part, what we do, we go to step 4. Is front equal to null, then go to step 5. What we do is set both front and rear to 0. Then if rear equal to max minus 1, let's go to step 8. Step 8, rear equal to rear plus 1. Then q of rear is step 9. In step 9, what we do here is q of rear, that is, assume this as q of rear. In this case, q of 0 is equal to element. So what is the element that we want to store? The first element what we are considering is 10. So q of rear is equal to element. So 10 is being placed in the location, and then we stop. So assume you call insert function once again. We are calling insert function once again now. So this, okay, let it be, it will be useful for the next iteration. Now next element which we want to insert next element called 20. We want to insert next element called 20. So the element now to be inserted is 20 here. Check this condition whether q is full. When we say q is full, whenever these two conditions are satisfied. Combining these two or this. So front is equal to 0 and rear equal to max minus 1. Both must be there. Front is equal to 0 and rear equal to max minus 1. Both must be satisfied. So front is equal to 0, but rear equal to max minus 1. No, it is not there. Because rear is pointing to index 0. Or front equal to rear plus 1. Is it there? So rear and front both are pointing to 0. That is also false. That means if this is the case, then only we'll go to step 3 and say q is full. Step 3 simply means for displaying q is full. In this case, we'll go to else part. What else part says? We have to go to step 4. We have to go to step 4. What happens in step 4? Check whether front is equal to null. That means still the queue is empty. There are no elements inserted into the circular queue. If this is case, we go to step 5. Else we go to step 6. In this case, we have to go for else part. What you have to do else part? Simply increment the rear. But before you increment, check whether rear is pointing to max minus 1. If rear is pointing to max minus 1, then it indicates that all the elements are occupied. Is rear is equal to max minus 1 in this case. Rear is pointing to 0. Max minus 1 is 4. It is not the case. If this is case, we go to step 7. What happens in step 7? We simply make rear to 0. We simply make rear to 0. When it comes back across the circle, as I explained when telling about the theoretical part, whenever you go on inserting and whenever you delete some elements, there will be some memory location available, then we increment the rear again. Now in this case, else part is true, we'll go to step 8. What we do in step 8? Simply we'll increment the rear and there we store the element. Make rear to point to next index and there you store the element. See what happens in step number 9. This q of rear equal to element. Q of rear equal to element. We're just storing the next element. Okay, rear is made to point to this location now, and we have inserted next element. So let us say we want to insert one more element. So that is 30. So check this, obviously it is false. Then we'll go to step 4. Front is equal to null. No, it is also false. We'll go to step 6. Whether rear is equal to max minus 1, false. We'll go to step 8. In step 8, what we do? We simply increment the rear. Increment the rear and there you store the element. Increment the rear, I'll go for full condition and there you store the element. Increment the rear and there you store the element. I have inserted, likewise I have inserted all the elements in the circular queue. Now we have come across some situation. And if you still want to insert one more element called 60, the circular cube is full. We are not supposed to insert one more element now. But still we have to write the code. We have to check as per the flow of algorithm. Check whether front is equal to 0 and rear is equal to max minus 1. Is it the case? Yes, it is the case. See here, this condition is being satisfied now. What it says? Front is pointing to 0 and rear is pointing to 4. What is that for? 4 is max minus 1. In this case, circular cube is full. We cannot insert new elements. We cannot insert new element. And the flow of algorithm will stop. The other case also I will explain. See here, to check the circular cube, two cases are there, either this or this. So when we get this condition, I'll explain that. Two more situations, what we can do, let us delete some elements, because the deletion we will discuss later. I will delete now. And we'll delete the elements from the front end. Once you delete this, you have to advance front. Front has to be made to point to this location, right? Let us delete one more element. You delete 20 and front has to point to 30 now. Front has to point to 30. Front has to point to 30. But there are still locations available in the circular cube. Now you can insert some more elements. If you can see this 60, now you can insert 60. Let us check the condition once again. Whether front is equal to 0 and rear equal to max minus 1, false. That means we have still space to insert some more elements. We'll go to else part. Check else part now. Go to step 4. Whether front is equal to null? No. Then go to step 6. Whether rear equal to max minus 1? Yes, it is true. Now step 6 is true for the first time. Is rear equal to max minus 1? Yes, rear is 4, max minus 1 is 4. That indicates that there are some free locations available. If rear equal to max minus 1, go to step 7. What step 7 says? Here, make rear to point to 0, because this 0th index is free here. It is understood that 0th index is free. What you do in step number 7, take rear and make it to point to 0. Take rear and make it to point to 0. Because that is what is the advantage of circular queue. We can go on using the memory locations. Then rear equal to step, one second, if rear equal to max minus 1, go to 7, else go to steps 8. Okay, when we have incremented C, when you have done this 7, we should not do this 8. Okay, else go to, okay, there is something is missing in the algorithm here. What they have to tell here is, if rear equal to max minus 1, go to step 7. So when you have set the rear to 0 here, again you should not go with the step 8. So here you should, after setting rear to 0, you should go to step 9 here. Something is missing here, you just correct it. Step 9. That's why we got stuck in the beginning when inserting first element. That I identified now. That is step 9, because once you set the rear to 0 here, again you should not increment once again rear. If you increment rear once again, it will come to this location. Rear will point to this location. That's why this step has to be skipped here. You should go to step 9. In step 9, what we do? In the rear index of the queue, simply store the element. In the rear index of the queue, simply store the element 60. Right? So likewise, if you call the insert function once again, that is inserting one more element called 70. Check this condition, front equal to 0, no, it is false. We will go to else part, else step 4, front is equal to null, no. That means we'll go to step 6. Step 6, rear equal to max minus 1. See, if rear equal to max minus 1, then only we'll go for step 7, else we'll go to step 8. What happens in step 8? Step 8 simply increment the rear and store the next element. And this is the scenario which will help us to check this condition now, or condition. We were checking for this condition to check the circular cube is full. If you check this first condition, front equal to 0 and rear equal to max minus 1, it is not true. If you check only this condition, it will still tell that circular cube is not full. But in this case, circular cube is full, because we have inserted all the elements, we have deleted 2 elements, and then we have inserted 2 more elements. In this case also circular cube is, circular cube is full. How do you check that? Front equal to rear plus 1. front is 2, rear is equal to 1. 1 plus 1 is 2. In this case also circular cube is full. This is how we insert, that is, this is how we insert elements onto the circular cube. That is code for inserting elements onto the circular cube. Right, so let us be in this scenario now. I think we still have some time. I can explain the delete operation also, but no, time is over. I will take delete operation in the next class. Deletion. The things will be still clear once we discuss about the flow of program. Flow of program. So insert is over. This delete operation followed by the implementation program, I'll cover it in the next class, because we don't have sufficient time now for that.